Hey, welcome to 6.3, which is going to be percent composition. Here's the warm up. There's 4 wonderful questions. How about you take a pause and then press play? Alrighty, let's check those answers. The first one, how many atoms are present in 19,697 AMU of gold? So we gotta check the periodic table because you gotta find the mass of gold. So 1 atom of gold, which happens to be AU, is 196.97 AMU of AU. So we are going to set this up like dimensional analysis. We are going to start with our 19,697 AMU of gold. Draw our cute little line. Because we started with AMU, the AMU will be at the bottom, 196.97 AMU of gold. 1 atom of AMU will be at the top. Put your parentheses there to show that it's a ratio because it is a fraction. You can cancel out your AMU of gold, leaving you with atoms. So when you do the math, you will get 100 atoms AU. Great job. How many moles are in 336 milligrams of barium? So this one, we're going to have to set up 2 different conversion factors to solve for this because we have to go from milligrams to grams and then to moles. You will start with 336 mg of barium. Draw your line. We know that 1,000 milligrams are in 1 gram. And that's just a prefix. Think about like milliliters, millimeters, milli, it's thousandths. So it's pretty small. And then now that we're in grams, we can look at the periodic table to see the mass of barium, which is 137.33 grams of Ba, is 1 mole of Ba. I put them in parentheses so we can easily see the difference between the ratios. Now we got to make sure all the units cancel. Mg barium, Mg, grams of something, grams of barium, leaving us with moles. When you put this into the calculator, instead of doing separate calculations each time, you can just enter it all in as one thing. So I would put in 336 parentheses, 1 divided by 1,000, close that parentheses again, 1 divided by 137.33, end parentheses, just because it will keep all those ratios there, especially if you're not sure when to divide or multiply when it comes to the fractions. I would just enter it as I see it. When you put that in this calculator, you're going to get a large number. I'm going to round off of sig figs, and 336 has 3 sigs. So if I round, I would get 0.00247 moles of barium. Let me box this answer as well. Now, the next one says, how many atoms are in 0.0015 grams of copper? We are going to start with 0.0015 grams of copper, which is Cu. So what's really nice is those masses that's off of the periodic table, all of those masses, when we're talking about grams, is 1 mole. 1 mole will always have Avogadro's number for the amount of atoms, which we could also say is molecules. So when I set this up, I can look for copper on the periodic table, and the mass is 63.55 grams of copper, and I know there's 6.022 times 10 to the 23rd atoms for every 1 mole. So grams of copper, you put this into the wonderful calculator. I'm going to round to 2 sig figs, so you should get 1.4 times 10 to the 19th atoms Cu. Now, what is the molar mass of phenol, which is C6H6O? Instead of writing them all out, I'm just going to show you another way to do them. So carbon, we know is 12.01. Hydrogen, we know is 1.01. And this one is 16. So if I was doing a shortcut way into the wonderful calculator, I would do 12.01 times 6, because there's 6 of them, plus 1.01 times 6, because there's 6 hydrogens, right? There's carbon, hydrogen, And then you have 16 times 1. And honestly, you don't have to do the times 1 because anything times 1 is itself. And I would just put that into the calculator exactly how I'm reading it, just to make sure I'm not dropping any decimals or anything. So let me do that really quick because I didn't do it previously. But if you add all of these together, you're going to get 94.12 grams per mole. And that's the molar mass of phenol. Now, here we actually go into the unit. So 6.3, which is percent composition, you're going to learn to find the mass percent of an element given in a given compound. So when we're thinking about mass percent, that's going to be the part divided by the whole. So it's going to be the mass of that element divided by the mass of the compound times 100, because we want it to turn into a percentage, which is percent is per 100. That's what centi means, like centuries or cents in a dollar. So let's practice some problems. You are going to calculate the percent composition of carbon in C2H5OH, which is ethanol. So if I'm going to write this all out, I have carbon, hydrogen, and oxygen. I have carbon, which is 12.01. There's 2 of them from C2, and that's 24.02. Hydrogen's mass is 1.01. By the way, these numbers in this column, those are off of the periodic table. The numbers in this column are from the compound. Right? So there's 6 total, 6.06. Oxygen is 16, and there's only 1 of them. And then you're going to add all these numbers together to get the molar mass, which is 46.08 grams per mole. So this is the molar mass, which you're going to need, right? So that's the mass of the compound. I'm looking for the percent composition of carbon, so I will take carbon's contributions, which is 24.02, divide it by the molar mass, which is the whole, 46.08, times 100, and I will get 52.13% carbon, which is super great. So the mass percentage or the mass composition of carbon in ethanol is about 52.13%. I usually like to go to just 2 decimal places. Makes life a little bit easier. If you want to go to 3 or just 1, that is really up to you. So find the percent composition of oxygen and rust. And I gave the name of rust, which is iron 3 oxide. Remember, this 3 belongs to iron. Oxide, which is how we get Fe2O3, which is a type 2 ionic compound. Same thing, I'm going to list out my elements, Fe and then O. Look for iron's mass on the periodic table, which is 55.85. And I have 2 of them. So 55.85 is going to give me 111.7. Oxygen is 16.00, and I have 3 of those. So that's going to be 48. Whoops. Oh, I clicked the wrong button. 48. And you want to add those together because you're getting the sum. And that's going to be 159.70 grams per mole. Remember, this is your molar mass. So your mass of the compound. You're going to find the percent composition of oxygen. Let me change colors. So oxygen, it was 48. The molar mass is 159. So it's the part divided by the whole times 100. And I'm just going to round to 2 decimal places. So I'm going to get 30.06% oxygen. So the percent composition of oxygen in iron 3 oxide, which is rust, 30.06%. Take a pause and calculate the percentages for each of the following compounds in these practice problems, and then press play to check your answer. Alrighty, so if we're looking at FeNO33, we have parentheses, and remember, whatever's in the parentheses is affected by what's on the outside, and it's going to multiply, right? And it won't multiply the Fe because it's not inside those parentheses. So, Fe, N, and O. 55.85 times 1, you get 55.85. N, which is nitrogen, is 14.01. There's 1 inside the parentheses times 3, because that's what's on the outside, is 3. So 14.01 times 3 is 42.03. Oxygen, which is 16. And 3 times 3 is 9. A lot of people will add, but you have to multiply. And you get 144. And where you want to add these all together to get the molar mass. And so you'd get 241.88 grams per mole. Now, you have to find the percent composition for each of them. So for iron, to calculate that, it'd be 55.85, because that's what iron is, divided by 241.88 times 100. So I'd get about 23.09% Fe, rounded to 2 decimal places. Now, if I wanted to do nitrogen, I'm going to do the 42.03 divided by the 241.88 times 100. And that's going to give me 17.38% nitrogen. And then oxygen, which is this last one, 144 divided by 241.88 times 100, and rounded that to 2 decimal places is 59.53. 53% oxygen. So these are the percent compositions for iron 3 nitrate. If you add them all up, they should equal 100 or close to 100. If I add these up, they will equal exactly 100. Awesome. Let's check this next problem. Potassium, chlorine, and oxygen. So potassium is 39.10, and they only have one of them. Cl, which is chlorine, 35.45, and I have 1. Oxygen, there's 4 of them. So 16 times 4 is 64. And you want to add all of these together, and you'll get 138.55. And that's the molar mass. So let's find the percentages for each element. We'll start with potassium, 39.1 divided by 138.55 times 100. Rounded to 2 decimal places, we're going to get 28.22% potassium. I'm going to change my color for chlorine, 35.45 divided by 138.55 times 100. We're going to get 25.59% chlorine. And now oxygen, you're going to take 64 divided by 138.55 times 100. And that's going to be 46.19% oxygen. Let's look at this last one. So you have calcium. You have 3 of those. You want to find that in the periodic table. Ca, 40.08 times 3. That's going to give you 120.24. Phosphorus, which is going to be 30.97. And there's 2 of them. because there's 1 on the inside, times 2 because of what's on the outside of those parentheses. You get 61.94. Oxygen is 16.00, and 2 times 4 is 8. So 16 times 8 is 128. You want to add all these together, and I'm running out of space. But if you add all of these together, it's going to be 310.18 grams per mole. Now again, I'm going to go through each one of those elements to get the percentage. Calcium is going to be 128.24 divided by 310.18 times 100. Calcium's going to round to 38.76%. And then phosphorus is 61.94 divided by 310.18 times 100. That's about 19.97% phosphorus. And I have to do oxygen all the way over here, so I have 128 divided by 310.18 times 100. And that's 41.27% oxygen. So this, wow, that looks really weird, is the percentages of each element in this wonderful compound. Good luck with your homework. Email me if you have any other questions. I believe in you.